In this particular example, we are still dealing with a cylinder whose volume is changing. What makes the question slightly more difficult is the radius and height are also simultaneously changing. Neither one of these is a constant. We start by writing down our equation for the volume of a cylinder. Volume is equal to pi r squared h. There are techniques to take the derivative of this particular expression, which has three variables, using something called implicit differentiation, but you haven't learned this technique yet. So there has to be another way of approaching this question. We only know how to take the derivative of functions, that is, expressions containing two variables. So we're going to have to take a slightly different approach. We're going to try to express r in terms of h or h in terms of r, depending on what the question is asking me to find. Since the question is asking me to find the rate of change in the volume with respect to the radius, or dV dr, I would like my equation to have only the variables v and r in them. For this reason, I am going to express h in terms of r. We know, based on the word problem, that the height is 3 times the radius, is always 3 times the radius. So h is equal to 3r. That's why in the second step of our solution, I've substituted 3r in for h. By doing so, I ultimately obtain the function, the cubic function in this case, v is equal to 3 pi r cubed. So now we're down to two variables, and we should have no problem taking the derivative using the power rule. dV dr is going to equal 9 pi r squared, and then it's simply a matter of substituting in 4 for r, because they ask us to find this particular rate of change at r equals 4. We obtain 144 pi meters cubed per meter, which can also be expressed as 452.40 meters cubed per meter.